Okay, so today we're going to be reviewing RFC 4752. The title of this RFC is the Kerberos V5 GSSAPI Simple Authentication and Security Layer SASL Mechanism. We're going to skip the status, the copyright. We're going to jump into the abstract. The Simple Authentication and Security Layer SASL is a framework for adding authentication support to connection-based protocols. This document describes the method for using the generic Security Service Application Program Interface, or GSS API, Kerberos V5 in the SASL. This document replaces Section 7.2 of RFC 2222, the definition of the GSS API SASL mechanism. This document, together with RFC 4422, obsoletes RFC 2222. I'm going to skip over the table of contents and jump into Section 1, Introduction. The specification documents currently deployed simple authentication and security layer mechanism supporting the Kerberos V5 generic security service application program interface mechanism in RFC 4121. The authentication sequence is described in Section 3. Note that the described authentication sequence has known limitations. In particular, it lacks channel bindings, and the number of round trips required to complete authentication exchange is not minimal. SASL WG is working on a separate document that should address these limitations. Section 1.1, Relationship to other documents. This document, together with RFC 4422, obsoletes RFC 2222 in its entirety. This document replaces Section 7.2 of RFC 2222. The remainder is obsoleted as detailed in Section 1.2 of RFC 4422. Section 2. This is about conventions. The keywords must not, should not, and may in this document are to be interpreted as defined in Keywords for use in RFCs to indicate requirement levels. Section 3. Kerberos V5 GSSAPI mechanism. The SASL mechanism name for Kerberos V5 GSSAPI mechanism is GSSAPI. Though known as the SASL GSSAPI mechanism, the mechanism is specifically tied to Kerberos V5, and GSSAPI's Kerberos V5 mechanism. The GSSAPI SASL mechanism is a client goes first SASL mechanism, i.e., it starts with the client sending a response created as described in the following section. The implementation may set any GSS API flags or arguments not mentioned in the specification as it's necessary for the implementation to enforce its security policy. Note that major status codes returned by GSS init sec context or GSS accept sec context other than GSS S complete or GSS S continue needed cause authentication failure. Major status codes returned by GSS unwrap other than GSS S complete without any additional supplementary status codes cause authentication and or security layer failure. Section 3.1, Client-side of authentication protocol exchange. The client calls GSS init sec context, passing in input context handle of 0 initially. Mech type of the Kerberos V5 GSS API mechanism, chan binding of null, and targ name equal to output name from GSS import name called with input name type of GSSC NT host-based service. An input name string of service at hostname, where service is the service name specified in the protocol's profile, and hostname is the fully qualified hostname of the server. When calling the GSS init sec context, the client must pass the integ rec flag of true. If the client will be requesting a security layer, it must also supply the GSS init sec context, a mutual rec flag of true, and a sequence rec flag of true. If the client will be requesting a security layer providing confidentiality confidentiality protection, it must also supply the GSS init sec context a conf rec flag of true. The client then responds with the resulting output token. If GSS init sec context returns GSS s continue needed, then the client should expect the server to issue a token in a subsequent challenge. The client must pass the token to another call to GSS init sec context, repeating the actions in this paragraph. Okay, so star, which this was in this text, there was a caveat for some of these sections. So this star, clients may use name types other than GSS CNT host-based service to import servers acceptor names, but only when they have a priori knowledge of the server's that the servers support alternate name types. Otherwise, clients must use GSS CNT host-based service for importing acceptor names. Note that RFC 2222 implementations will not work with GSSAPI implementations that require integrec flag to be true. No implementations of RFC 1964 or RFC 4121 that require integrec flag to be true are believed to exist, and it is expected that any future update to RFC 4121 will require that integrity be available even I think if not explicitly requested by the application. When GSS init sec context returns GSS s complete, the client examines the context to ensure that it provides a level of protection permitted by the client's security policy. In particular, if the integ-avail flag is not set in the context, then no security layer can be offered or accepted. If the conf-avail flag is not set in the context, then no security layer with confidentiality can be offered or accepted. If the context is acceptable, the client takes the following actions. If the last call to GSS init set context returned an output token, then the client responds with the output token. Otherwise, the client responds with no data. The client should then expect the server to issue a token in a subsequent challenge. The client passes this token to a GSS unwrap and interprets the first octet of the resulting clear text as a bit mask specifying the security layers supported by the server, and the second through fourth octets as the maximum size output message the server is able to receive, in network byte order, or big Endian. If the resulting clear text is not 4 octets long, the client fails the negotiation. The client verifies that the server maximum buffer is 0 if the server does not advertise support for any security layer. The client then constructs data with the first octet containing the bit mask specifying the selected security layer. The second through fourth octets containing in network byte order the maximum size output message the client is able to receive, which must be 0 if the client does not support any security layer, and the remaining octets containing the UTF-8 encoded authorization identity. Okay. Implementation note: the authorization identity is not terminated with the zero valued octet or hexadecimal 00 octet. E.g., the UTF-8 encoding of the null or U plus 0000 character. Right, so the client passes the data to GSS wrap with conf flag set to false and responds with the generated output message. The client can then consider the server authenticated. 3.2 Server-side of authentication protocol exchange. A server must not advertise support for the GSSAPI SASL mechanism described in this document unless it has acceptor credential for the Kerberos V5 GSSAPI mechanism. The server passes the initial client response to GSS accept sec context as input token, setting input context handle to 0 initially, chan binding of null, and a suitable acceptor cred handle. If GSS accept sec context returns GSS s continue needed, the server returns the generated output token. to the client in challenge and passes the resulting response to another call to GSS accept sec context, repeating the actions in this paragraph. Servers should use a credential obtained by calling GSS acquire credential or GSS add cred for the GSSC no name, desired name, and the object identifier or OID of the Kerberos V5 GSSAPI mechanism. Servers may use GSSC no credential as an acceptor credential handle. Servers may use a credential obtained by calling GSS acquire cred or GSS add cred for the server's principal name and the Kerberos V5 GSSAPI mechanism. Unlike GSS add cred and GSS acquire cred, the GSS acquire cred uses an OID set of GSS API mechanism as an input parameter. The OID set can be created by using GSS create empty OID set and GSS add OID set member. It can be freed by calling the GSS release OID set. Use of servers principal names having GSSC NT hostbase service name type and service at hostname format, where service is the service name specified in the protocol's profile and hostname is the fully qualified hostname of the server, is recommended. The server name is generated by calling GSS import name with input name type of GSSC NT hostbase service and input name string of service at hostname. Upon successful establishment of the security context, i.e. GSS accept sec context returns GSS S complete, the server should verify that the negotiated GSS API mechanism is indeed Kerberos V5. This is done by examining the value of the mech type parameter returned from the GSS accept sec context call. If the value differs, SASL authentication must be aborted. Upon successful establishment of the security context, and if the server used GSSC no name, GSS like /GSSC no credential, to create acceptor credential handle, the server should also check using the GSS inquire context such that the target name used by the client matches either 1. the GSSC NT hostbase service, which is the service at hostname name syntax, where service is the service name specified in the application protocol's profile, or 2. the GSS KRB5 NT principal name name syntax for a two-component principal where the first component matches the service name specified in the application protocol's profile. When GSS accept sec context returns GSS S complete, the server examines the context to ensure that it provides a level of protection permitted by the server's security policy. In particular, if the integ avail flag is not set in the context, then no security layer can be offered or accepted. If the conf avail flag is not set in the context, then no security layer with confidentiality can be offered or accepted. If the context is acceptable, the server takes the following actions. If the last call to GSS accept sec context returned an output token, the server returns it to the client in a challenge and expects a reply from the client with no data. Whether or not an output token was returned, and after receipt of any response from the client to such an output token, the server then constructs 4 octets of data, with the first octet containing a bit mask specifying the security layers supported by the server, and the second through 4th octets containing, in network byte order, the maximum size output token the server is able to receive, which must be 0 if the server does not support any security layer. The server must then pass the plaintext to GSS wrap with conf flag set to false and issue the generated output message to the client in a challenge. The server must then pass the resulting response to GSS unwrap and interpret the first octet of resulting cleartext as the bit mask for the selected security layer, the second through 4th octets as the maximum size output message the client is able to receive in network byte order, and the remaining octets as the authorization identity. The server verifies that the client has selected a security layer that was offered and that the client maximum buffer is 0 if no security layer was chosen. The server must verify that the source name is authorized to act as the authorization identity. After these verifications, the authentication process is complete. The server is not expected to return any additional data with the success indicator. Section 3.3, Security Layer. The security layers and their corresponding bit masks are as follows. 1. No security layer. 2. Integrity protection. Sender calls GSS wrap with conf flag set to false. And 4. Confidentiality protection. Sender calls GSS wrap with conf flag set to true. Other bit masks may be defined in the future. Bits that are not understood must be negotiated off. When decoding any received data with GSS unwrap, the major status other than the GSSS complete must be treated as a fatal error. Note that the SASL negotiates the maximum size of the output message to send. Implementations can use the GSS wrap size limit call to determine the corresponding maximum size input message. Section 4, IANA considerations. IANA modified the existing registration for GSSAPI as follows. A family of SASL mechanisms. No. SASL mechanism name. GSSAPI. Security considerations. See Section 5 of RFC 4752. Published specification is in RFC 4752. And then we've got person and email, a bunch of other things. Let's go to Section 5. Security considerations. Security issues are discussed throughout this memo. When constructing the input name string, the client should not canonicalize the server's fully qualified domain name using an insecure or untrusted directory service. For compatibility with deployed software, this document requires that the CHAN binding, or channel bindings, parameter to GSS init set context and GSS accept set context be null, hence disallowing use of GSS API support for channel bindings. GSS API channel bindings in SASL is expected to be supported via a new GSS API family of SASL mechanisms to be introduced in a future document. Additional security considerations are in the SASL and GSS API specifications. Additional security considerations for the GSS API mechanism can be found in, they have a link, and Kerberos. Then we have acknowledgements. And we've got Section 7, Changes since RFC 2222. RFC 2078 specifies the version of GSS API used by RFC 2222, which provided the original version of this specification. That version of GSS API did not provide the integ avail flag as an input to GSS init sec context. Instead, integrity was always requested. RFC 4422 requires that when possible, the security layer negotiation be integrity protected. To meet this requirement, and as part of moving from RFC 2078 to RFC 2743, this specification requires that clients request integrity from GSS init set context, so they can use the GSS wrap to protect the security layer negotiation. The specification does not require that the mechanism offer the integrity security layer, simply that the security layer negotiation be wrapped. And then they have a section 8 on references, a bunch of interesting references that you could go look deeper into. And then there's the editor's address, Alexei Melkinov. And let's actually go back to the acknowledgements. This document, Section 6 acknowledgements, this document replaces Section 7.2 of RFC 2222 by John G. Myers. He also contributed significantly to this revision. Lawrence Greenfield converted text of this document to the XML format. Contributions of many members of the SASL mailing list are gratefully acknowledged, in particular comments from Chris Newman, Nicholas Williams, a bunch of different people here. And that's basically it. I won't pretend that I understood that very much. This was the first time that I read through this. But as is the way with this series, I'm trying to learn just as much as I'm trying to, I guess, give people an audio version of this that might be useful to them. Maybe, because I'm reading it and this stuff is sort of awkward to read sometimes, I apologize for, not saying things with the right cadence, or some of this stuff is just like hard to imagine in your mind. I would assume if you were just listening to this, it'd be kind of confusing maybe at times, but still better than nothing if you're just trying to get exposed to this whole thing. So anyways, that's just kind of a short and sweet RFC 4752 titled the Kerberos V5 GSSAPI Simple Authentication and Security Layer Mechanism. If you're interested in becoming like a great programmer, and you would like to follow me in some of the other things that I do, you can watch more of the videos on this channel, or you can visit my programming blog that is at pieharbor.com. I'll have a link for that in the description. I think I'm also going to link this RFC. So thanks for listening, and I'd appreciate any feedback about making this whole system of reading this stuff and reviewing it. I think I'm going to have videos that are like more about actually reviewing something, that like not just reading it out loud, reviewing it more. But I'm going to be doing a lot of these reading ones first, since I have to like actually read it to understand it. But anyways, leave comments if you have some suggestions about how I could do things better. And thanks.